Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. You can find information about online seminars and study manuals for exams PFM, IFM, and LTAM at these websites that I indicated here. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. You are given that n has a Poisson distribution with mean 4. Find the variance of n given that n is greater than or equal to 4. Let x be a Bernoulli trial defined as x is equal to 1 if n is greater than or equal to 4, and x is 0 otherwise, but otherwise means simply that n is less than 4. Then the probability of success for x, so probability that x is 1, is the probability that n is greater than or equal to 4, and that's 1 minus the probability that n is 0, minus the probability that n is 1, minus the probability that n is 2, minus the probability that n is 3. And of course the probability of hitting a specific number, n, by a Poisson random variable is e to the minus lambda times lambda to the nth, where n is that number, over n factorial. So we use that for n equal to 1, 2, 3, and 4, and plug into that formula, do the calculation. This comes out to be 1 minus 71 over 3 times e to the minus 4. That's approximately 0.5665. Also, the variance of n, which is 4, because that's the parameter of this Poisson distribution, is equal to the expected value of the variance of n given x plus the variance of e of expected value of n given x. Now, n given that x is 1 is n given that n is greater than or equal to 4, and n given that x is 0 is n given that n is less than 4. So the variance of n given x is equal to the variance of n given that n is greater than or equal to 4 when x is 1, and it's the variance of n given that n is less than 4 when x is 0. And the expected value of n given x is the expected value of n given that n is greater than or equal to 4 when x is 1, or the expected value of n given that n is less than 4 when x is 0. And we can rewrite this as expected value of n given that n is less than 4 times plus 1 times the difference between the expected value of n given that n is greater than or equal to 4 and the expected value of n given that n is less than 4. And that's what this is equal to when x is 1, because then things cancel out and we get the expected value of n given that n is greater than or equal to 4 for the first case. But for the second case, when the second expression is multiplied by 0, we get the expected value of n given that n is less than 4. So this means that this e of n given x is equal to the expected value of n given that n is less than 4 plus the difference of those two expected value of n given that n is greater than or equal to 4 minus the expected value of n given that n is less than 4 times this Bernoulli trial that we work with, 1 when x is 1 and 0 when x is 0, so that e of n given x is a multiple of a Bernoulli trial with a constant added to it. Also, the expected value of the variance of n given x is p times the variance of n given that n is greater than or equal to 4, plus 1 minus p times the variance of n given that n is less than 4, because that expression variance of n given x is equal either to the first value with probability p or the second value with probability 1 minus p. Well, from the fact that e of n given x is a multiple of a Bernoulli trial with a constant added to it, we see that the variance, well, the variance doesn't care about the constant, so the variance is equal to the variance of that Bernoulli trial, p times 1 minus p, times the square of the difference of those two expected values, times the square of the thing that is multiplied by the Bernoulli trial. Combining these two with the fact that 4 is equal to the variance of n, which is the expected value of the variance of n given x, plus the variance of of the expected value of n given x, we get this. That 4, which is variance of n, is equal to p times variance of n, given that n is greater than or equal to 4, plus 1 minus p times the variance of n, given that n is less than 4, plus p times 1 minus p times the difference of the two expected values squared. Also, 4 is the expected value of n, but it's the expected value of the expected value of n given x. So it's equal to p times the expected value of n given that n is greater than or equal to 4 plus 1 minus p times the expected value of n given that n is less than 4. That's p times expected value of n given that n is greater than or equal to 4 plus 1 minus p times, well, the expected value of n given that n is less than 4 is each value that n can have there, which is 0, 1, 2, 3, multiplied by its probability, which is the probability of hitting that value by n, but divided by the probability that we're in the region where n is less than 4, which is 1 minus p. But 0 times anything is 0, so we disregard the 0, and this just becomes 1 times the probability that n is 1 over 1 minus p, plus 2 times probability that n is 2 over 1 minus p, plus 3 times probability that n is 3 over 1 minus p. And of course, all these values can be calculated. 1 minus p cancels out, so p disappears from it, and we just need to find 1 times probability that n is 1, plus 2 times probability that n is 2, plus 3 times probability that n is 3. And that whole expression now is simplified to p times e, expected value of n given that n is greater than or equal to 4, plus 52 times e to the minus 4. So from this we can actually figure out what the expected value of n given that n is greater than or equal to 4 is. It's equal to 4 minus 52 e to the minus 4 over p. And p is 1 minus 71 over 3 e to the minus 4, so we plug that in, and we calculate it, and it's approximately 5.3794. Furthermore, probability that n is n given that n is less than 4 is the probability that n is n intersection n is n intersection with n less than 4 over the probability that n is less than 4. And for n equal to 0, 1, 2, 3, that's the same as probability that n is n over probability that n is less than 4, so it's probability that n is n over 1 minus p. That's the same reasoning we just used. So that n given that n is less than 4 is 0 with probability e to the minus 4 over 71 over 3 times e to the minus 4, 1 with probability 4 e to the minus 4 divided by 71 over 3 times e to the minus 4, 2 with probability 8 e to the minus 4 over 71 over 3 times e to the minus 4, and 3 with probability 32 over 3 times e to the minus 4 over 71 over 3 times e to the minus 4. And after we calculate this, this ends up saying that this is equal to 0 with probability 3 over 71, 1 with probability 12 over 71, 2 with probability 24 over 71, and 3 with probability 32 over 71. Well, based on this, the expected value of n, given that n is less than 4, is just each value multiplied by its probability. This ends up being 156 over 71, which is approximately 2.1972. And the second moment, e of n squared, given that n is less than 4, is 0. Each value squared multiplied by the probability. This ends up being 396 over 71. So that the variance of n, given that n is less than 4, is 396 over 71 minus 156 over 71 squared. This ends up being 28,116 minus 24,336 over 71 squared, or 3,780 over 71 squared, which is approximately 0.7499. So that, now we bring that value back to the previous equation we had, in which we had the 1 minus p times the variance of n, given that n is less than 4. We're actually trying to establish that value to bring it all to the previous equation. So 1 minus p times variance of n, given that n is less than 4, is 71 over 3 times e to the minus 4, which was 1 minus p, times 3780 over 71 squared. This ends up being 1260 over 71 times e to the minus 4. That's approximately 0.3250. And now we bring it all back to this equation that said that variance of n is p times variance of n, given that n is greater than or equal to 4, plus 1 minus p times the variance of n, given that n is less than 4, plus p times 1 minus p times e of n, given that n is greater than or equal to 4, minus e of n, given that n is less than 4, that difference squared. So 4 is the variance of n. P times variance of n, given that n is greater than or equal to 4, is 1 minus 71 over 3 times e to the minus 4, times the variance of n, given that n is greater than or equal to 4, which is the quantity we're looking for, plus 71 over 3 times e to the minus 4, times 3780 over 71 squared, plus 1 minus 71 over 3 times e to the minus 4, times 71 over 3 times e to the minus 4, times 4 minus 52 e to the 4th over 1 minus 71 over 3 e to the minus 4th, minus 156 over 71, the whole quantity squared. And we would just patiently calculate all the numbers that we have here. The only unknown is the variance of n, given that n is greater than or equal to 4. Everything else can be calculated, and then the unknown can be found. So based on this, we end up finding that variance of n, given that n is greater than or equal to 4, is approximately equal to 4 minus 0.3250 minus 2.4868 over 0.5665. That's approximately 2.0973, which is answer A. Please remember, this is copyrighted material. The problem is created by me, was created by me back in 2008. The solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on the test.